So we have a dam wall in the shape of a trapezoid. Now this dam wall has a top length of T, a bottom length of B. The height of the water is little h, and the height of the trapezoid is big H. Now this dam is displayed as this, pretend that attaches, and the water is coming through this way. And so what we want to find is the horizontal force being exerted on this trapezoid face from the water. So we know that force is equal to pressure times area. But for this specific scenario, we know that pressure distribution changes as the depth decreases. So we're going to have to express this as an integral. So instead of F equals P times A, we're going to change this to the integral of the area times pressure times dA. Now we know that pressure is equal to rho GH. And now we also know that if we have this trapezoid and we take a small sliver of this trapezoid, that any one of these slivers or bands across this trapezoid is at a constant pressure. So we're going to call this sliver dA. And we're going to call the height of this sliver dH. And we're going to call the width W. So now we can change our integral to area rho GH W times dH. But now we need to make an expression to represent W, because W changes as well as the depth increases. So now we know that the top W of this trapezoid, the highest width it can be, is equal to T, and the lowest width it can be is equal to the bottom, B. Then we also know that this trapezoid decreases at a constant rate, a constant slope. So we know that width at a depth of 0 is equal to T, and the width at the deepest part is equal to H, is B. So then we have T minus B over H minus 0. We can simplify that to T minus B over H. And then we can have the width of little h is equal to T minus B over H times little h. So now we have, if we want to plug in our area, 0 to the height of the water, rho GH T minus B over H times little h dH. And then we can simplify this further. So we know that the horizontal force exerted by the water on the dam can be expressed as rho G, we'll pull that out, 0 to the height of the water. And then by simplifying this, we have T little h minus T minus B over large H. This is times H squared, all ODH. And this is our expression.